Hi, welcome to Bill's Machine Shop. It's a new hobby of mine. It's a relaxation from just doing magnetometers. I've always been considered a well-rounded guy. I like to ski and do magnetometers, and I've discovered there are other things too. Okay, I'm squaring up a piece of work in the lathe. Preparation for turning it down. It's a little bit tedious because this is a 4-jaw chuck, which is not self-centering, and it means that it's much more versatile, but also a lot harder to set up. I try to set it up so it doesn't have more than a couple of thousandths of an inch run out. If you're making things like flywheels, it's really important to not have them run out because it'll vibrate quite wildly. I'm going to show you turning a piece of work on my new lathe. It's an amateur lathe, not as heavily built as the machine shop. You can see I'm turning down a piece of brass here, the outer diameter, to clean it up. I can do it under manual power like as I'm doing it, or I can stop the thing and engage the lead screw. So now you can see it's feeding automatically. And by doing that, you get a much more uniform cut. If you're advancing it manually, you do herky-jerky. The downside is you've got to watch it because you don't want your tool running into the chuck. Anyway, the lathe is useful for turning round stock. And over here I have a mill. The mill is better for working with flat pieces, and they're both fun to work with. I've made a lot of modifications to it. I've added an air spring rather than a mechanical spring. I've added digital readouts so that I can get a precise indication of where the work is, and it's a huge help for making things accurate. And to date, I've made a few engines just as a hobby thing. What I have here is it's called an oscillating steam head, and you'll see the reason it is that the movement, this is the cylinder and the piston, but they both move together. And the timing ports in the back, here's the in port where we put either steam or compressed air. Compressed air I have, steam I might have at some point. And then the side is an exhaust port, so when the engine is over in this location, air gets injected and forces the piston down. When it comes across the other side, the air is expelled from here, allowing the piston to make an upstroke. Since it's a single piston, you have to have it in the right starting orientation so that it can actually receive air. So I put it there, and then I'll It's a rotary valve type engine. The way it works, there's an aluminum cylinder in here, and it has a hole drilled here inside the cylinder so that when the engine is at this location, it ejects the air to the steam stack. You inject steam or hot or air in this one, and it forces the thing to move. All right, the elements of this engine, it has 2 cylinders, and it's called a single action because the reason it's a single action is both receive energy at the same time rather than having alternating timing. And you can see here's the crank. It has a stainless steel piston. It's a 316 alloy stainless, and I'll never use that again. It's like trying to machine kryptonite. It's really very difficult. The timing is here are set screws at the back, which lock the cylinders to the valve. And the timing, if you get that wrong, the engine won't run. So now I'll demonstrate how much smoother this is. One of the figures of quality for a steam engine like this is how slow can you run it. And it has to be a really good engine to run slowly.